The pressurization system on the A320 normally operates automatically to adjust the cabin altitude and rate of change of altitude to ensure maximum passenger comfort and safety. The pressurized areas are the cockpit, the avionics bay, the cabin, and the cargo compartments. The concept of the system is simple. Air is supplied from the air conditioning packs to the pressurized areas. An outflow valve is used to regulate the amount of air allowed to escape from the pressurized areas. Automatic control of the outflow valve is provided by two cabin pressure controllers. Each controller has an electric motor to move the outflow valve. A controller-motor combination is known as a system. Only one system will operate at any one time, with the other system acting as backup. A third motor is installed for use in the event of both automatic systems failing and requires a manual input to open or close the outflow valve. To avoid excessive cabin differential pressure, safety valves are installed. Let us look at the operation of the outflow valve for an aircraft in cruise and what happens to cabin differential pressure, cabin altitude, and cabin vertical speed. We will start with cabin differential pressure. If the outflow valve is closed or only allowing a small amount of air to escape, then the cabin differential pressure will increase. Now let's look at what happens to cabin altitude. If the outflow valve is closed or only allowing a small amount of air to escape, then the cabin altitude will descend. We can also see what the cabin is doing by reference to vertical speed. When the outflow valve closes, the cabin altitude will decrease, negative vertical speed. If the outflow valve is fully open, a lot of air is allowed to escape. The cabin pressure will decrease, the cabin altitude will climb, positive vertical speed. The crew can monitor all cabin pressure functions on the ECAM cabin pressure page. Let's look at the information associated with the pressurization system that is presented on the cabin pressure page. The pack indication is displayed green when the associated pack is on. The outflow valve position can be monitored and the system controller in use is shown. There is a single indication for the safety valves. We will look at how this indication changes in the abnormal operation module. The cabin differential pressure, or delta P, shows the difference in PSI between the cabin pressure and external pressure. This differential pressure will be at 0 on the ground and increase as the aircraft climbs. The cabin vertical speed shows the rate of change in feet per minute of cabin altitude. For passenger comfort, the pressurization system will aim to keep this rate of change as small as possible. The cabin altitude is also shown. The vent, inlet, and extract indications are associated with the avionics ventilation system and will be discussed in a separate module. On the ECAM cruise page, there are indications of cabin differential pressure, cabin vertical speed, cabin altitude. There is also an indication of cabin vertical speed on the ECAM door page. Note that this indication is only displayed when the aircraft is airborne. On the overhead panel, there is a cabin pressure panel containing controls to operate the pressurization system. Under normal conditions, no pilot action is required on this panel during flight. The pressurization mode select switch has two settings: automatic and manual. The normal position for this switch is lights out. In this position, the pressurization system is in automatic mode. The use of manual mode and the manual vertical speed control will be discussed in the abnormal operation module. The landing elevation selector normally remains in the auto position. Landing elevation, which is required by the pressurization system, is then provided by the FMGS based upon elevation of the destination airport. If the landing elevation is not available from the FMGS, then it can be set manually using this selector. You will use this selector in the abnormal operation modules. The guarded ditching switch is provided to close all valves below the waterline so that the aircraft can be sealed in the unlikely event of a ditching.